This is SpaceTime Series 24 Episode 2 for broadcast on the 6th of January 2021. Coming up on SpaceTime, a breakthrough in measuring the power of the strong nuclear force. Mystery surrounds a dark storm on the planet Neptune. And the maiden flight of China's new reusable Long March 8 rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have made the first precision measurements of the forces acting between protons and exotic subatomic particles called hyperons, particles which contain strange quarks. The measurements are not only groundbreaking for nuclear physics, but also key to understanding neutron stars, which are among the most puzzling and fascinating objects in the universe. Positively charged protons and atomic nuclei should repel each other. And yet even heavy nuclei with many protons and neutrons stick together thanks to the strong nuclear force. The strong nuclear force, which binds quarks together to form subatomic particles like protons and neutrons, is one of the four fundamental forces of nature. The others being the weak nuclear force, which causes radioactive decay, electromagnetism, which transmits energy and light through photons, and gravity, which may actually not be a force at all, but simply the effect of mass on the fabric of space-time. Quarks are elemental subatomic particles and a fundamental constituent of matter. They combine to form composite particles called hadrons, the most stable of which are the protons and neutrons which make up the atomic nuclei. There are 6 known types of quarks, known as flavors: up, down, top, bottom, sometimes called beauty, and charm and strange. The up and down quarks have the lowest masses. The proton is composed of 2 up quarks and a down quark, while the neutrons are made of 1 up quark and 2 down quarks. The heavier quarks all rapidly change into up and down quarks through a process of particle decay, the transformation from a higher mass state to a lower mass state. Now, because of this, up and down quarks are generally stable, and they're the most common type of quark in the universe, whereas strange, charm, top and bottom quarks can only be produced in high-energy collisions, such as those involving cosmic rays or in particle accelerators. One of the biggest challenges in nuclear physics is understanding the interaction of gluons, which carry the nuclear force, and the different flavors of quarks from first principles. Knowing this could then be used to determine the strength of the interaction. However, experiments to determine the strong interaction hyperons, which contain 1 or more strange quarks, are extremely difficult because hyperons are unstable and decay rapidly after production. This difficulty has so far prevented any meaningful comparison between the theory and experiment. And that's where Professor Laura Fabietty and colleagues from the Technical University of Munich come in. They've developed a way to precisely measure the strong nuclear force using subatomic particle collisions using the ALICE detector at the European Organisation for Nuclear Research's Large Hadron Collider, the world's largest atom smasher located under the Franco-Swiss border near Geneva. The new method provides high-precision measurements for the forces acting between protons and hyperons. Fabietty and colleagues used a technique called femtoscopy to study the strong nuclear force. This technique allows investigating spatial scales close to 1 femtometer, some 10 to the power of minus 15 meters, about the size of a proton, and the spatial range of the strong force action. A report in the journal Nature shows how the authors were able to use ALICE to analyze experimental data for most of the hyperon-nucleon combinations, and measure the strong nuclear force for the rarest of all hyperons, the omega, which is made up of 3 strange quarks. Understanding the interaction between hyperons and nucleons is also extremely important for testing the hypothesis of whether neutron stars contain hyperons. That's because the forces existing between the particles will have a direct influence on the size of a neutron star. So far, understanding the relationship between the mass and radius of a neutron star remains unknown, and as this report from the Technical University of Munich shows, Fabietty's work will therefore help solve this riddle.
For physicists, neutron stars are puzzling. What form does matter take inside them? And what is the relationship between their radius and their mass? Only a few things are clear. The surface of a neutron star consists of neutrons, and the matter density increases from the outside in. And neutron stars are compact. They have radii of about 11 kilometers, but masses of 1 or 2 suns. One of the hypotheses that has to be tested to solve the puzzle is whether there is strange matter inside a neutron star, meaning nucleons with strange quarks. Our world is made up of atoms. Atomic nuclei consist of nucleons, positively charged protons and neutrons, which in turn are composed of 3 quarks. There are 6 different types of quarks, with only the up and down quarks forming stable nuclei. The heavier, strange quarks do not normally occur in our environment. If a nucleon includes 1 or more strange quarks, it is called a hyperon. To check whether neutron stars contain hyperons, we need to know more about the forces between the particles. For a given mass, repulsive forces increase the radius. Attractive decrease it. Hyperons can be produced and studied at the LHC particle accelerator at CERN in Geneva. In a proton-proton collision at the experiment ALICE at the LHC, around 20 new particles are created, including hyperons. They are unstable and decay almost instantaneously, but can be recognized by their reconstructed trajectories. By observing a proton-hyperon pair that leaves the collision center in parallel, the interaction can be measured. If their trajectories remain close, the force is attractive. If they diverge, the force is repulsive. The ALICE experiment succeeded for the first time in determining the strong interaction between protons and hyperons with high precision. Even for the rarest of hyperons with 3 strange quarks, the omega hyperon. In the future, physicists strive to measure the forces between 3 particles. With these results, they will finally be able to solve the riddle of the neutron stars.
Astronomers are trying to understand the mysterious behaviour of a dark storm on Neptune, which has suddenly changed direction and may even have spawned a second storm in the process. A meeting of the American Geophysical Union has been told that the massive dark vortex was being monitored by scientists ever since its discovery by NASA's Hubble Space Telescope in September 2018. Neptune is the Sun's 8th most distant known planet, orbiting at an average distance of 4.5 billion kilometres, 30 times further out than the Earth. The giant blue planet has an average radius of 24,622 kilometres and an atmosphere composed primarily of hydrogen and helium, along with traces of hydrocarbons and possibly nitrogen. It also contains a high proportion of ices such as water, ammonia and methane, making it an ice giant rather than a gas giant. The dark vortex the scientists have been observing is a storm wider than the Atlantic Ocean, which was born in the planet's northern hemisphere. Observations showed that it followed the usual path of such storms on Neptune, slowly drifting south towards the equator, where these vortexes usually dissipate. However, much to everyone's surprise, 7,400-kilometre-wide storm suddenly changed its direction in August 2020, instead heading back north, a behaviour never seen before by any other Neptune storm. And equally puzzling, the storm wasn't alone. Hubble spotted another smaller dark spot in January 2020, which temporarily appeared near the larger vortex. Named Dark Spot Junior, it was around 6,300 kilometres wide. Astronomers think it might have carved off from the larger vortex before drifting away and dissipating. The larger storm was the 4th dark spot that Hubble has observed on Neptune since 1993. 2 other dark storms, the Great Dark Spot and the Scooter, were discovered by the Voyager 2 spacecraft in 1979 as it flew by the planet, but they had disappeared before Hubble could observe them. Neptune's dark vortices are actually high-pressure systems that form at mid-latitudes and then slowly migrate towards the equator. They start out remaining stable due to the Coriolis effect, which causes northern hemisphere storms to rotate clockwise due to the planet's rotation. These storms are unlike cyclones or hurricanes on Earth, which rotate counterclockwise in the northern hemisphere because they're low-pressure systems. However, as these Neptunian vortices drift towards the equator, the Coriolis effect weakens and the storms disintegrate. Now, in computer simulations by several different teams, these storms have always followed a more or less straight path to the equator until there's no more Coriolis effect to hold them together. But unlike the simulations, this latest giant storm didn't migrate towards the equatorial kill zone. Hubble observations also revealed that the dark vortex's puzzling path reversal occurred at about the same time dark spot Junior first appeared. And Junior appeared near the side of the main dark spot that faces the equator, the location that some simulations show a disruption would occur. However, the timing of the small spot's emergence was unusual. It's possible that shedding the fragment caused the larger storm to change its course and move away from the equator. But it's all really guesswork because scientists don't even know how these storms actually form. It might be due to an elevated dark cloud layer, and that could be telling astronomers something about the storm's vertical structure. Another unusual feature of the dark spot was the absence of any companion clouds around it. These were present in Hubble images taken when the vortex was first discovered in 2018. Apparently the clouds disappeared when the vortex halted its southward journey. The bright clouds form when the flow of air is perturbed and diverted upwards over the vortex, causing gases to likely freeze into methane ice crystals. And so the lack of clouds could be revealing more information about how these spots evolve. This is SpaceTime. Still to come, China launches its new reusable Long March 8 rocket, and we look at the highlights of 2020 through the eyes of the European Space Agency. All that and more still to come on SpaceTime. China has launched its new reusable Long March 8 rocket on a maiden test flight. The new 50-metre tall medium-lift launcher blasted off from the Wenchang Satellite Launch Center on Hainan Island, carrying 5 spacecraft into orbit. Beijing claims the satellites are conducting experiments in space sciences, remote sensing and communications technologies. This is SpaceTime. Still to come, 2020 described as a challenging year for the European Space Agency, and later in the science report, compounds found in cooked meats linked to a heightened risk of childhood wheeze. All that and more still to come on SpaceTime. "2020 has been a challenging year for the European Space Agency. There was the successful launch of Solar Orbiter on a journey to explore the Sun, Sentinel-6 on a mission to monitor the Earth's rising oceans, and Eutelsat Connect, which has revolutionized telecommunications. The year also saw the maiden flight of the new Vega SSMS, which has heralded a low-cost new launch system for small satellites, deploying new technologies such as FullSat and ESAIL. The Gaia and Cheops space observatories yielded new findings about the universe. ESA and NASA continued development of the new Orion capsule and service module. It'll be used to return humans to the surface of the Moon in 3 years. And the two agencies also agreed to build a new Lunar Gateway space station. But there's also been significant delays because of things like the COVID-19 coronavirus pandemic. The victims have included the new Vega C and Ariane 6 launch vehicles, as well as their associated launch infrastructure, and the new reusable Space Rider orbital spacecraft. COVID-19's dramatically impacted ESA operations, with many scientists and engineers forced to remotely work from home. There's also seen its share of failures, such as the loss of a Vega rocket carrying a Spanish Earth observation satellite. This report from ESA TV.
2020 has been a productive year for ESA despite the challenges of a global pandemic. The much-anticipated Solar Orbiter was launched in February, and its 10 instruments were tested in situ for the first time. With unrivaled protection against heat and light, it can get closer to the Sun than any previous spacecraft. Its observations of solar activity have already exceeded all expectations. The beginning of the year also saw the launch of Eutelsat Connect, built by Thales Alenia Space as an ESA partnership project. This high-throughput satellite will increase broadband coverage, bridging the digital divide between Africa and Europe. After grounding due to a failure in July, ESA's Vega launcher returned in September with the first deployment of SSMS, a new modular dispenser designed to provide affordable launch opportunities for multiple small satellites. Amongst the 53 satellites on board was ESAIL, a high-performance instrument for tracking ships worldwide. Also on board was FISAT, ESA's first demonstration of how artificial intelligence can be used to enhance Earth observation technology. Meanwhile, development continued on the new Vega C launcher, which will be able to return hardware to Earth using the integrated Space Rider re-entry vehicle. Work also continued on Ariane 6, which will be available in both 2 and 4 booster configurations. ESA's Earth observation capabilities were showcased throughout 2020, with Sentinel-6 launched in November. Using the latest radar altimetry technology, this will continue a 4-decade program of sea level measurements, essential to help mitigate the effects of climate change and protect vulnerable communities. As the older Sentinel-1 tracked a huge iceberg off the coast of Georgia, the Soil Moisture and Ocean Salinity mission continued to provide crucial data for agriculture, more than a decade after its launch. ESA responded to the global pandemic by cooperating with NASA and JAXA on the COVID-19 Earth Observation Dashboard, and with the European Commission on the Rapid Action Coronavirus Earth Observation Dashboard. These use satellite data to monitor the impact and recovery from environmental changes caused by the coronavirus lockdown. Throughout the COVID pandemic, the European Space Operations Centre managed to keep complex operations going. Despite the challenges of remote working, it was possible to capture these stunning images of Earth during the April flyby of Bepi Colombo. Other space science projects included exoplanet hunter Cheops, which in September revealed one of the hottest planets ever recorded, WASP 189b. And on December the 3rd, results were released from the Gaia Space Observatory, showing the most detailed ever catalogue of stars in our Milky Way. On the human spaceflight front, 2020 saw the return of ESA astronaut Luca Pamitano, who landed on the Kazakhstan steppes in February after a 201-day mission to the ISS. The next astronaut to fly will be Thomas Pesquet, who has spent the year preparing for the upcoming Alpha mission, launched by the SpaceX Crew Dragon. In October, ESA and NASA also signed the historic Memorandum of Understanding, which will see member states contribute elements to Gateway, the first human outpost in lunar orbit. As Europe continues its exploration, steps are being taken to ensure safety in space. A contract was signed with the Swiss company ClearSpace to remove orbiting debris, with ambitious plans to capture a Vega payload adapter in 2025. ESA also gave German company OHB the green light to start development of Hera, ESA's first planetary defense mission to deflect asteroids. This is complemented by a new fly-eye telescope in Milan, Italy, also developed by OHB. 2020 has been a challenging time for the world. ESA has worked hard to overcome setbacks and achieve its goals, leaving us well-placed to pursue a brighter future in space.
And time now to take another brief look at some of the other stories making news in science this week with a science report. Well, the debate is now officially over. A comparison of data from over 130,000 hospitalised patients in France has confirmed that the COVID-19 coronavirus is more severe than the flu. A report in the Lancet Medical Journal claims nearly twice as many people were admitted to hospital for COVID-19 at the height of the pandemic than were admitted for influenza at the peak of the 2018-2019 flu season. Death rates among hospitalised COVID-19 patients were 3 times higher than the flu. More patients with COVID-19 required intensive care. The average stay in ICU for COVID-19 was nearly twice as long. And although fewer children aged under 18 were hospitalised with COVID-19 compared to the seasonal flu, a larger proportion of those aged under 5 required intensive care for COVID-19. The COVID-19 coronavirus has now killed close to 2 million people and infected some 80 million others since first spreading out of Wuhan, China last year. Inflammatory compounds found in cooked meats have been linked to a heightened risk of childhood wheeze. The compounds, known as advanced glycation end products, are produced by high-temperature cooking, such as grilling, frying or roasting, with cooked meat a major dietary source. Researchers looked at over 4,000 children aged 2 to 17, including around 500 who experienced wheezing over the past year. A report in the journal Thorax found higher advanced glycation end product scores were linked to increased odds of wheezing, disturbed sleep due to wheezing, wheezing during exercise, and wheezing requiring medication over the past year. A new study claims the Arctic appears to be experiencing a record-breaking number of lightning strikes, and the trend looks likely to continue increasing. A report in the journal Nature claims the increase is another sign of global climate change. The observations were made by the Worldwide Lightning Location Network, a collection of ground-based sensors that measure and record lightning data. The change could have a significant impact on the region, which has already seen a record number of wildfires in recent years. A new study has found that 4-month-old ravens are just as intelligent as chimpanzees and orangutans in cognitive skills. The findings, published in the journal Scientific Reports, examine the spatial memory, understanding the differences between more or less and what adding things together means, the ability to understand that an object still exists when it's out of sight, and the ability to communicate with and learn from a human experimenter. Scientists found that the cognitive performance of ravens remains similar from the ages of 4 to 16 months, suggesting that the speed at which a raven's cognitive skills develop is relatively rapid and already near to complete by the age of 4 months. And that's interesting because it's at this age when ravens become more and more independent from their parents and they start to discover their ecological and social environments. Comparing the cognitive performance of ravens with those of chimpanzees and orangutans who completed similar tasks, the authors found that with the exception of spatial memory, the cognitive performance of the ravens was very similar to those of the apes. A new study has found that 46% of Australian children aged between 6 and 13 now have their own cell phone. That's up from 41% just 5 years ago. But with things like cyberbullying and sexting becoming a bigger issue than ever, how do you keep your kids safe? With the answers, we're joined by Alex Zaharov-Reutt from ITWire.com.
There is research in Australia, and it would probably be something similar in the US, where in Australia, just under 46% of Australian children aged between 6 and 13 are using a mobile phone in 2020, up from 41% in 2015. So the Australian Mobile Telecommunications Association has put out some suggestions for parents to consider when buying their child their first mobile phone. And of course, one of the first things is be aware and use the parental controls available on both iOS and Android that allow you as a parent to set screen time limit and also to limit the types of apps that are available to be downloaded and used so that the children aren't getting apps that are for a higher age group. And also to be sure that the kids are not overusing their phones. I mean, there are stories of children who are up till 2 in the morning or longer playing games or chatting with people that are perhaps age inappropriate. And in the old days, you used to say, leave the computer in the living room, not in the child's bedroom. But today, the computer is held in your hand. So definitely, you want to make sure you're checking that out. You are protecting your child's privacy by making sure that the kids are not, for example, on Facebook or Twitter if they're under 13, a lot of kids are. Set those screen time limits, understand cyberbullying that often happens from the friends that the child has at school, not just on certain apps. And know the school's policy on mobile phone use. I mean, a lot of parents are now considering for the younger children getting these smart watches, which are mobile phones, so that the child can have a way of being contacted and being tracked and doing messages, but can't use that phone to be cheating on homework or cheating in school or not paying attention in class. And some of the schools don't allow phones at all. So a watch sometimes is a way around that so you can stay in contact.
Something I was considering for a while there was going to a cell phone only lifestyle. I came very close to it, especially when I was, although based in one city, working out of another, where I had a separate apartment, really didn't need the burden of an extra set of landlines and things like that. What's the latest thinking on that?
So, well, during the ADSL days, now of course with a lot of the fibre to the node and fibre to the home connections were using something called VDSL or fibre directly to home, with VDSL being a more advanced form of ADSL. But back in the ADSL days, in the mid-2000s, there was a thing called naked DSL, where you didn't have to have a phone line switched on to get your internet connection. Now, these days, a phone line is so cheap, the phone service association is just bundled in, and really, you're not going to get any discounts if you don't want that. But a lot of people are now using the internet through mobile devices, mobile broadband, and they're also simply not using the phone line at home at all, because often you get phone calls from companies trying to sell you electricity plans, solar plans, and people trying to rip you off. And so, for example, at home, we have a 100 megabit connection, and we don't use the home phone anymore because it just rings off the hook with people trying to scam us for something, and we just don't use it at all, and there's no discount for switching it off. So in Australia, back in 2015, only 29% of people were mobile only for voice, but in 2020, this has jumped to 60% of Australian adults, and that's with a mobile but no landline. And mobile only for internet was 16%, but strangely, that's down from 21% in 2015. And 12% were mobile only for both voice and internet at home. And this has remained largely unchanged since 2015, where it was 11%. So, look, the ability for people to live a completely mobile life, for mobile broadband and mobile voice, has never been simpler and easier, with much more mobile coverage than we've ever had before. But plenty of other people, they get their broadband connection and the phone line is just bundled in. And, you know, I've been living a largely wireless life for many years as well. And it's one less bill you have to worry about, one less phone to answer, and one less hassle in your life.
And that's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.